In this section, we will describe fullerenes and graphene. There are other structures that carbon atoms can form other than diamond and graphite. One example is fullerenes. In these structures, the carbon atoms will join together to make large hollow cages which can have all sorts of shapes. In this figure, we have the first fullerene to be discovered, which contained 60 carbon atoms. Now, scientists can make giant fullerenes that contain many thousands of carbon atoms. The name of this compound is Buckminster fullerene. So the name of this molecule containing 60 carbon atoms is Buckminster fullerene. So these are hollow-shaped molecules of carbon, and the structure is based on hexagonal rings of carbon atoms. So as you can see over here, there are 6 carbon atoms forming a hexagon. 1, 2, 3, 4, 5, and 6. Actually, fullerenes may also have rings of 5 or even 7 carbon atoms. Cylindrical fullerenes are called carbon nanotubes, which can also be produced. Actually, these fullerenes will form thin cylinder, so it's a cylinder whose length is much greater than their diameter. So it's a large, thin cylinder. And due to their shape, they have very useful properties. So they have high tensile strength, which means that they can be used to reinforce composite materials, and they have high electrical conductivity and high thermal conductivity. That's because they have delocalized electrons. So because of their thermal and electrical conductivity, they are used in the electronics industry. Moreover, fullerenes could also be used for drug delivery into the body. And they can be used as catalysts because of the large surface area to volume ratio of their nanoparticles. So fullerenes are one type of allotropes of carbon, where the structure of the fullerene is based on hexagonal rings of carbon atoms. Let's now describe graphene. Actually, if we can separate a single sheet of carbon atoms from graphite, we can get a layer of interlocking hexagonal rings of carbon atoms, which is just one atom thick, and the new material is called graphene. So here we have graphite. We will try to get a layer of interlocking hexagonal rings, which is just one atom thick. Now we obtain the graphene. Actually, graphene is an excellent conductor of thermal energy and electricity, and it's even better than graphite. In addition to that, it has a very low density and it's the most reactive form of carbon. Graphene can also be used to make quicker and more powerful computer chips.